Today's topic of discussion is external work done by an expanding gas at constant pressure and at constant volume. So first we will take the external work done by an expanding gas at constant pressure. Suppose we take a piston in which we have some gas, right? Now we move this piston and we compress this gas, and the final position of the piston is this black one, right? So, and we have assumed that the area of cross section of the piston is area of cross section is a area of cross section equals to capital A, and force applied is equal to F, right? Force applied is equal to F. Now what happens if we apply a pressure here or force here, then it is converted into pressure, and the value of pressure is equal to F into A, F into A, and this is the pressure. Now what happens is that if we give the gas a pressure, the gas itself will apply a pressure on this piston in the opposite direction, on this piston in the opposite direction. Suppose initially we are giving a pressure on the gas, we are giving a pressure on the gas in this direction, right? The gas itself will apply a pressure on the piston in this direction. So the value of this force which the gas applies on the piston is the same, right? Is the same. So force is same or pressure is same because area is constant. So, and now when the gas applies this pressure, the piston has moved the distance x. The piston has moved the distance x, means external work done by the gas. Suppose we have applied a pressure, the piston has come to this point. Now we have withdrawn this force, and now the gas applies the same force to this piston and moves it back to its original position. Let this distance be x. Let this distance be x. Suppose this is x distance. X distance. So work done by the gas, work done is equal to, my mistake, that force is not, uh, wait, no mistake, pressure is not F into A, pressure is F by A, pressure is force divided by A. So work done is equal to, work done by the external gas is force into displacement, force into displacement. And what is force? Force is pressure into area. Let pressure be E into area into X. So this is the work done. Now A into X. What is A into X? A into X is nothing but a change in volume. Suppose in this point the volume was V1, and in this point the volume is V2. Right? So change in volume is A into X, and it is equal to V2 minus V1. Initial final volume minus initial volume, V2 minus V1. So this is the amount of work done by an expanding gas at constant pressure. This is the amount of work done by an expanding gas at constant pressure. Now, what will happen at constant volume? What will happen at constant volume? Instead of pressure, if we take constant volume, what happens? At constant volume, V2 minus V1 is 0, means there is no change in volume. If there is no change in volume, if there is no change in volume, then the amount of work done is 0. If there is no change in volume, then the amount of work done is 0. If there is no change in volume, then the amount of work done is 0, because work done, if there is no change in the position of the piston, then work done will always be 0. So you should always remember that at constant volume, an expanding gas does do any work, does not do any work. Now at constant volume, the process is known as isoporic process. Constant volume, the process is known as isoporic isoporic, and at constant pressure the process is known as isobaric. Isobaric, right? Isothermal process will not consider because the internal energy of a given amount of gas does not depends only upon its temperature, right? So we will not consider that process. So this is the expressions. External work done by an expanding gas at constant pressure was P into V2 minus V1, and external work done by an expanding gas at constant pressure, that is isoporic process, is 0.